Hello everyone, welcome to Neso Academy. We are learning theory of computation. Until now we have understood what is a Mealy machine and what is a Moore machine. So now in this lecture, that is construction of Mealy machines, we are going to understand how to construct a Mealy machine. So in this lecture, we will solve total 3 problems on construction of Mealy machines. Let's get started with our very first problem. Construct a Mealy machine that prints A whenever the sequence 10 is encountered in the input string. Otherwise, it will print B. What does that mean? It simply means that we are required to construct a Mealy machine that will produce the output symbol A whenever we get the sequence 10 in our input string. And otherwise, it will produce the output B. So let's take an example. Suppose we have an input string 1, 0, 1, 0, 0. So this is the input string. Now, the first input symbol is 1. 1 is not equal to 1, 0. That means, till now we have not got the sequence 1, 0. In that particular case, the output will be B. So the first output symbol will be B. Now the second input symbol is 0. And after I get the second input symbol 0, I am getting the sequence 1, 0. And on getting the sequence 1, 0, the output will be A. So the second output symbol will be A. Now the third input symbol is 1 and 0, 1 is not equals to 1, 0. Again the output will be B only. After that I am getting 0. So I have got the sequence 1, 0. So the output will be A. And the last input symbol is 0. 0, 0 is not equal to 1, 0. We are not getting the sequence 1, 0. That is why the output will be B. So this is the output string corresponding to the given input string. And you can see in all the cases, output is B only in one condition. That is, whenever we get the sequence 1, 0, the output is A. So why are we getting output A only 2 times in the output string? Because in the input string, only 2 times we are getting the sequence 1, 0. This is the first occurrence of 1, 0 and this is the second occurrence of 1, 0. That is why the output symbol A occurs only 2 times. In all the other cases, the output symbol is B. So this is the Mealy machine that we are required to construct as per the given problem. But if right now you are not able to think how to construct such a Mealy machine to produce the output symbols like this, then no worries. First, we will start from the construction of DFA. So let's first make a DFA for accepting the strings that are ending with the sequence 1, 0. So let's start constructing the DFA. We have our initial state that is Q0 and the simplest possible string is 1, 0 because 1, 0 itself ends with 1, 0. That means 1, 0 will be accepted by our DFA. So the first symbol is 1 and the second symbol is 0. It will be accepted. Now to make it a complete DFA, we need to complete all the transitions. Q0 has a transition for 1, but it doesn't have a transition for 0. So I will simply create a self loop of 0 over the state Q0. Because if the string is ending with 1, 0, it doesn't matter how many 0 comes before that. Now let's talk about the state Q1. Q1 has a transition for 0, but it doesn't have a transition for 1. So again I will simply create a self loop of 1 over the state Q1. Because now also my string is ending with 1, 0. Now let's talk about the state Q2. It doesn't have a transition for input symbol 1 as well as for input symbol 0. So we need to create both the transitions. Now the string is already ending with 1, 0. And if 1 comes after 1, 0, if 1 comes after 1, 0, then we need to go back to the state Q1 so that my string ends with 1, 0. And if 0 comes after 1, 0, then it will destroy the whole pattern. So if 0 comes, I need to go back to the initial state Q0 so that I can get 1 0 again in the ending of the string, and my string will get accepted by this DFA. So this is the deterministic finite automata for accepting the strings ending with the sequence 1 0. But our goal is to construct the Mealy machine. And I have explained you, in finite automaton with output, there is no concept of final or accepting states, because our main focus is on output generation rather than accepting or rejecting the input strings. That is why we will remove this particular final state from our DFA. And now, in order to complete this particular Mealy machine, we need to add output symbols along with input symbols on the transitions. So as per the given question, Mealy machine will print A whenever the sequence 1 0 is there. Otherwise, it will print B. So when I get the sequence 1 0 here I am getting the sequence 1 0. Then the output will be A. So I am getting the output A only when I am getting the sequence 1 0. Otherwise, it will print B. So in all other inputs, we are having the output only B. Because as per the question, in all the other conditions, output symbol is B. Only in one condition, that is, when we are getting the sequence 1 0, the output will be A. So this is the final Mealy machine that we are getting for this particular problem. Now let's verify the same input string that we have taken initially. That was 1 0 1 0 0. This was the string that we have taken. Let's start from the first input symbol, which is 1. And we are on the initial state, that is Q0. Now Q0 on input symbol 1, the output is B. So the output symbol is B. And we are now on the state Q1. Next input symbol is 0. Now Q1 on 0 goes to Q2 and output is A. So this time we are getting the output A. Third input symbol is 1 and we are on the state Q2. So on getting input symbol 1, we will reach the state Q1 and the output is B. Now the next input symbol is 0 and we are on the state Q1. On getting 0, we will reach the state Q2 and output is A again. Now the last input symbol is 0 and we are on the state Q2. Q2 on 0 gives Q0 and the output symbol is B. So here we will write B. So this is the output corresponding to the given input string when we have processed the transitions with respect to this particular Mealy machine. And this output is same as the output that we have verified initially. That means this Mealy machine is appropriate and well tested for all the input strings. It will generate the output A whenever the sequence 1 0 is detected, and otherwise it will print the symbol B. So I hope this particular problem is now clear to you. Let's move towards the second problem. Construct a Mealy machine that produces the ones complement of any binary input string. What does that mean? It simply means that we are required to construct a Mealy machine that produces the ones complement of any input binary string. Now I hope you all know the meaning of ones complement. To get the ones complement of any binary number, we simply need to flip all the bits of that binary number. So we need to change every 1 to 0 and every 0 to 1 to get the ones complement. So if the input string is 1010, then output string will be 0101. 1 becomes 0 and 0 becomes 1. That is called as ones complement. Now we need to construct the Mealy machine that will give the ones complement of any input binary string. Let's start constructing the Mealy machine. And trust me, it is one of the easiest problem that you will get. So we have the initial state, that is Q0. On getting the input symbol 0, the output symbol is 1. and on getting the input symbol 1, the output symbol will be 0. And that is the required Mealy machine for this particular problem. I don't think in whole TOC there would be something more easier than this particular problem. So this is the Mealy machine that will produce the ones complement of any input binary string. Let's verify this with an input string. Suppose we have taken the input string 1, 0, 1, 0. Now the first symbol is 1. So we will follow this transition, this particular transition. So if the input symbol is 1, output is 0. So the output will be 0. Next symbol is 0. So if the input symbol is 0, the output is 1. Next we have 1. So if the input is 1, output is 0. And if the input is 0, this particular transition input is 0, output will be 1. So this is the ones complement that we are getting for this particular binary input string. So I hope this problem is now clear to you. Let's move towards the third problem. Construct a Mealy machine that produces the 2's complement of any binary input string. This means that you are required to construct a Mealy machine that produces the 2's complement of any binary input string. In the previous question, we have constructed the Mealy machine to calculate the ones complement. And this time we are required to construct the Mealy machine to calculate the 2's complement of a binary number. So what is a 2's complement? Let's find out. Suppose this is an input binary string. Now to calculate the 2's complement, we first need to calculate the ones complement. And I have explained you, we can get the ones complement by flipping all the bits of this input binary number. So the ones complement will be 0, 1, 0, 1, 1. This 0 becomes 1, this 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. This is how we have calculated the ones complement of this input binary string. Now in order to calculate the 2's complement, we need to perform the binary addition of this ones complement and the binary number 1. After performing this particular binary addition, we will get our 2's complement. Let's perform. 1 plus 1 is 0, carry 1. 1 plus 1 is again 0, carry 1. 1 plus 0 is 1, 1 is 1, 0 is 0. So 0, 1, 1, 0, 0 is the 2's complement that we have calculated for this particular input string. Let's take a different example for your better understanding. This time we have the input string 1, 1, 1, 0, 0. First we need to calculate the ones complement. So this is the ones complement. 0 becomes 1 and 1 becomes 0. Now to calculate the 2's complement, we need to perform the binary addition of ones complement with the binary number 1. 1 plus 1 is 0, carry 1. 1 plus 1 again 0, carry 1. 1 plus 0 is 1, this 0 is 0 and this is also 0. So we are getting the 2's complement as 0, 0, 1, 0, 0. So we have calculated the 2's complement of this particular input string also. Now, do you think it is convenient for us to construct a Mealy machine with this particular logic? That is, first we need to find the ones complement, then we need to perform the binary addition to get the 2's complement. No, it is not convenient at all. This is highly inconvenient to construct such a Mealy machine which is performing these two operations. That is why we need to develop a different logic to calculate the 2's complement directly from our input string. Let's try to find out the logic. So first you have to focus only on the input string and the 2's complement. And you need to tell me, do you find something interesting? Input string and 2's complement. Do you find something interesting? See, this 0 is same, this 0 is same, this 1 is also same. And after this 1, 0 becomes 1 and 1 becomes 0. So I hope you find a little bit logic. This is called as LSB, least significant bit, and this is called as MSB, most significant bit. And when we are moving from least significant bit to most significant bit, that is from right to left, we will find that before the first one comes, that is, these two zeros are coming before the first one. So these two are as it is in the 2's complement also. This 0 is same, this 0 is also same. When the first one comes, that is also same. But after the first one, all the bits are flipped. That is 0 becomes 1 and 1 becomes 0. I repeat the logic. When we move from LSB to MSB in the input string, that is from right to left, before the first one comes, all the bits are same in the 2's complement. When the first one comes, it is also same. But after the first one, all the bits are flipped. Or we can say, all the bits are 1 complemented. 0 becomes 1 and 1 becomes 0. Let's verify this logic with the second example also. This 0 is same, this 0 is also same. When the first one comes, it is also same. And after the first one, 1 becomes 0 and this one also becomes 0. That means our logic is correct. So we can write the logic like from LSB to MSB, that is from LSB to MSB, right to left. Until the first one arrives, 2's complement is same as the input string. Until the first one arrives, that is before the first one arrives, the 2's complement is same as the input string. After the first one, all the bits are flipped or 1 complemented. When the first one comes, it is also the same, but after the first one, all the bits are flipped. 0 becomes 1 and 1 becomes 0. That is the logic behind the Mealy machine that we need to construct. So we need to keep in mind this particular logic while constructing the Mealy machine. Let's try to construct our machine. So we are having our initial state, that is Q0. Now, before the first one comes, all the zeros will be same in the 2's complement. So until the first one comes, if the input is 0, the output will also be 0. When the first one comes, it will also be copied same in the 2's complement. But after the first one, when 0 comes, it will become 1. And when 1 comes, it will become 0. That is, our logic is justified by this machine. From LSB to MSB, until the first one arrives, 2's complement is same. That is, until the first one arrives, 2's complement is same. If the input is 0, output is also 0. When the first one arrives, it is also same. But after the first one, all the bits are complemented. 0 becomes 1 and 1 becomes 0. So this is the required Mealy machine for the given problem in which we need to calculate the 2's complement of any binary input string. Now one thing is left to mention in this particular solution, which you need to write in your exam. That is assumption. Input string is processed from LSB to MSB. In all the previous questions, we always processed the input string from MSB to LSB, that is, from left to right. But this time we have processed our input string from right to left. So we have taken this particular assumption. That is why we need to mention this point, that input string is processed from LSB to MSB while solving this particular question. And that is our assumption. So I hope this problem is now clear to you. Now, before ending this lecture, I have one homework problem for you. Construct a Mealy machine that gives output 1 whenever the substring BAB is detected in the input string. Otherwise, outputs 0. So in this question, you are required to construct a Mealy machine that will give the output 1 whenever the substring BAB is detected in our input string. Otherwise, it will output 0. So you have to follow the same approach. First, you need to construct the DFA for accepting the strings ending with BAB. Then you need to convert that DFA into the Mealy machine. So you have to remove the final state, and then you need to write all the output symbols along with the input symbols by developing the right logic. I hope you all can do this question. And once you do this question, kindly write "done homework" in comment section. So in this way, we are done with construction of Mealy machines. In the next lecture, we will begin with the construction of Moore machines. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.